Hey guys, what is up? So what I have for you today in this update video on BTM II is I'm actually going to be showing you a different type of Fibonacci sequence along with the updates made to it. Now if you watched my last video, uh, you'll notice that in this one it has a program counter on it just to, or yeah, it 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 has a display for what line of ROM it's on, as well as the flag register. Now, it also has 32 lines of ROM instead of 16, so it is at 50% capacity for right now. And also, I added in 32 bytes of RAM, and I'll get to the reason why here in a little bit. So, this program, while yes, it is the Fibonacci sequence, this one is running a little bit slower, but that's just because it is doing more things. Now, what it is doing is every time it calculates a Fibonacci number, it saves that number into RAM. And of course, it saves each number in a different location, which means that I need a way of basically taking the address line and incrementing it, which is actually exactly what uh, this register right here is for. It just sends the address to the RAM, or sends the RAM address to it, instead of having to program, if I can fly, program it into the actual program itself, which allows the program to be much smaller and allows it to be put into a loop. Now this program is fairly big. It takes up 17 lines of ROM, 18 if you include the halt instruction. So with that being said, uh, now as you can see, it is actually saving the Fibonacci sequence. Now, of course, it's just 1, 1, 2, 3 for right now, but over time it will actually start getting bigger numbers. This program actually took me a few hours to actually get working, mostly because I had to make a few changes to the actual hardware itself. Uh, I had to put in this redirection circuit because originally it just went from here to up here. Uh, However, while this is the least significant bit, this one is actually supposed to be the most significant, so that's the reasoning on that. Uh, and that's actually exactly what this is all doing. Uh, the reason for that is just so the least significant bit is always on this side, just so I don't have to deal with adding extra repeaters in this specific area for the data in bus. And of course I have it set up to where it also displays on the user interface, otherwise there's really no point in actually running the program if you cannot see what it's doing. Now this program does take about 14 minutes to complete, which means that at about the 10-minute mark it will skip a few seconds, but that's just because of how I have to record my videos. And this does actually lag my Xbox a tiny bit depending on what it's doing. Uh, when it starts getting into the bigger numbers, you will actually notice that Uh, Even though this all updates at the same time, one will update and then after a few seconds the rest will actually show up here. And that's just because of how many pistons are firing, how much repeaters is going on, how often it has to update the redstone, and what strength it is. So, and while yes, you could bypass this by actually making the computer slower, either by adding in more repeaters and delaying the clock, honestly, my Xbox can still handle it, which I did find a limit to what it can do. I found a limit, and of course I'm just going to stop the clock real quick just to fly over to it. Alright, so if I fly over here, now these are two builds that are very similar, uh, that one and that one. They are both binary to decimal decoders and decimal to binary decoders. I the For the video showing these two, I was originally going to have them both hooked up to one signal, mostly the 32-bit input, and just show a speed comparison. However, as soon as I flipped that lever to see the comparison before I started to record the video, instead of it actually working, it actually crashed the game. And let me just fly back over here to resume the program. Uh, when I say crash the game, I don't mean like the game completely crashed and sent me to the Xbox home screen. What I mean by it crashing is redstone no longer worked, it no longer rendered in your stuff relative to your location in the world, and it basically froze everything. You were still able to build and move around in the loaded chunks, but as far as actually, uh, like, okay, if you got it to where your game froze like that, and again, like I said, you were still able to build in there, you place down a lever, a piece of redstone, just one piece of redstone, and a piston connected to that piece of redstone. It would not work. It will not fire. It will not do anything. You can flip the lever. You can flip the lever as many times as you want, but it will not update. And funny enough is also if you break a block that the redstone is on, normally the redstone breaks, right? Well, in that case, the redstone stays just floating there without any actual block under it. So, yeah, that's a weird glitch in Minecraft, but it does actually show me what the limit is on it. And honestly, I think I'm going to try to reach that limit up with this computer, not necessarily because I can, although that is one of the reasons. It'll also show me what the limitations are as far as how big it can be, what all can be happening at the same time, and what will be, uh, I guess, acceptable, if that if that makes any sense to you guys. So then that will set the baseline and make it to where, okay, this is the max I can do. What can I do to make this computer faster, more powerful, and reduce the amount of work that it actually has to do? And now it's actually starting to get into the bigger numbers where this uh, where the display output for the user interface is actually lagging quite a bit. So let's see here. I have about 30 seconds left before I have to pause this recording and take another and start the recording again. So I'll see you guys in a few seconds. For you would be instant. Alright, I am So, we are just now reaching the end of the Fibonacci sequence. It has one more number to update, and it is technically an improper number. I could go through and change that. Uh, I still need to actually write out the program on on my laptop or a piece of paper or something, then actually look at it without actually requiring there to be torches or something. And then from there I can figure out how to make this program a little bit more efficient. But it just finished the first loop, so it's it just got it's now loading the initiation for the second loop, which is it's just loading 1 into register 0, and then it is taking register 2, uh, subtracting it, subtracting register 1 from it and saving it back to register 2. And then it's also reading from RAM, saving it to register 1, and then loading register 1 to the user interface, which, as you can see, it's it does like the pistons pretty bad. Now, when this loop is over, it will go to this halt indicator right here, or this halt instruction, and from there, like that instruction says, it completely halts the computer, brings it to a complete stopping point, does not let the program counter update. So yeah, I think from here I am just going to let you guys watch this countdown in Fibonacci. So I hope you guys enjoyed. If you liked the video, feel free to leave a like and possibly consider subscribing, because I am planning on posting more content like this in the future. So I'll see you guys in the next one.